Okay, so last week we talked about simple interest and the promissory notes and how they work. This week we want to go the next step and look at, we mentioned it briefly at the end of last class, but we want to spend some time talking about simple discount notes. Now remember how we described this last time. What we're used to is a simple interest-bearing note, where you get a principal amount, interest is added to it, and at the end you pay back a larger amount. Well, in a discount note, there is a face value of that note. Let's say we have a note with a face value of $6,000. In a simple interest-bearing note, a face value of $6,000 means you get $6,000 and you pay back more. In a simple discount note, a face value of $6,000 means at the end you're going to pay back $6,000. So, face value $6,000, let's say that our terms are that this is 6% for 120 days. Now, on a simple interest-bearing note, we talked about principal, interest, and then maturity value. Maturity value is what you paid back, which is the face value or the principal plus the interest. On a discount note, instead of interest, we talk about a discount. The way you figure out a discount is the same as figuring out the interest for a simple interest-bearing note. Principal times rate times time. Well, our principal here is the $6,000, the starting amount or the face value. The rate is what? 6%, so 0.06, always as a decimal. The time. Well, the time is in days, so we're going to use 360 or 365.
360.
Yeah, if it does not say, you always assume ordinary, which is 360. Yep, so it'll be 120 over 360. We're going to leave it as the 120 over 360 for now, just because it doesn't always work out so neat. So that means this is what, $120 in interest? If we multiply that out. For those of you following along in the calculator, it would be just 6,000 times 0.06 times 120 divided by 360. Yes, $120 in interest is correct. So that is the interest, but is in a discount note, it's what we call the discount. Now, instead of adding that on to our principal to figure out what we're going to have for a maturity value, what we're going to pay back at the end, what we're going to do here is we're going to subtract that from the principal. So 6,000 minus 120 is $5,880. This number right here is what we refer to as the proceeds. The proceeds in a simple or discount note is the amount you're actually going to receive from the bank. So even though this is a face value of $6,000, you will only receive $5,880. At the end, you're going to pay back how much? $6,000. So either way, it's $120 worth of interest. It's just you start out with a little bit less and you pay back the face value here. On that simple interest-bearing note, you started out with the face value, you added the interest, and you paid back a little bit more.
So it's better because it's a lower rate?
For the bank, it's better. Let me show you why.
If you're going to
borrow money, you want to borrow on a simple interest-bearing note, exact interest instead of ordinary interest.
No discount.
No discount, no. Let me show you why. Because the interest was calculated off of that $6,000 face value, and you didn't receive the full $6,000, you've effectively paid more interest. You would have paid $120 on an interest-bearing note, but you would have got the full $6,000 instead of just $5,880. So it brings us to a discussion of something called an effective interest rate. or just an effective rate. The effective rate involves us still using that formula, I equals PRT. Only now we're going to put in honest numbers. The interest, we know that was $120. That was the discount. The principal is not really $6,000. It's really $5,880. We're going to recalculate a new rate, so we're just going to put R back in there. And the time is 120 over 360. So now we have 120 here. We have to combine the 5880 and the 120 over 360. So 5880 times 120 divided by 360. 1960 R. And now what do we need to do? We need to divide by 1960 to get R by itself. 120 divided by 1960 is 0.0612. We normally round to about 4 or 5 decimal places. I'm going to go one more, so 6122. That's my rate. Now that's the rate, but really what we're looking for is a percent. What would that be as a percent? Yeah, we got to move that decimal point over 2 slots. So 6.122%. And let's say you're told to round it to the nearest hundredth of a percent. What's that going to be? 6.12%. So notice, even though everything was calculated with 6%, it really came out to be 6.12%. Any questions? I realize the color is horrible up there tonight. I'm going to head down to the ITV office in a little bit, and I'll grab on break, and I'll grab a new connector. I think we got a bad connector is all. Well, let's try another example of that. So let's say we have face value of $14,000. A simple discount note. Our terms, 7.2% interest for 90 days. You guys tell me where to start. I want you to find 3 things. Discount, proceeds, and the effective rate. It's basically the interest. Yeah. I know it's kind of confusing. I was just calling it interest last week, and now I'm calling it discount. So where do I start? So 0.072 is the percent, or the rate now. 90 over 360 is my time. Perfect. Which will give us $252. Works for me. So $252 is our discount. Find the proceeds. What's our next step? Perfect. 14,000 minus 252. 13,748. That is the proceeds. And then perfect. We put it back into the I equals PRT formula to find an effective rate. Everybody see where those, anybody have a question on where any of these numbers came from in here? The 252 is just the discount we calculated up here, that interest amount. The 13,748 is just our proceeds here. And the 90 over 360 is just our time from the original problem. And we're looking for a new rate, or a real rate, or an effective rate. So this is going to be 252 equals 13,748 times 90 over 360 is going to be what? 3,437. Is that right? 3,437. Then what? Divide by 3,437. So 252 divided by 3,437 is 0.07332. Usually 5, just in case you're asked to round to the nearest hundredth percent. So let's say I ask you to round this to the nearest hundredth percent. Since the original percent was given to the nearest tenth, it would make sense that I'd want to go at least one digit past that. So the nearest hundredth percent, this is going to be what? 7.33. Good. Move it 2 spots, 7.332. Rounding it there, the 2 is less than 5. Yeah.
I got a 9.
Punch something wrong?
Oh,
Okay, yeah, because it was 0.073319. Yeah. Then the 9 tells you to round the 1 down to 2. Put the 9 in the wrong spot. Okay. There you go. That's the effective rate. I'm going to have you guys try one here. We're giving you a face value of $12,000 on terms of 9.7% for 180 days. I'm going to give you guys a few minutes to do that. I'm going to run down and see if I can get a new connector, and I'll be right back. So first, let's start off. Did you get it? What did you get for an effective rate? What's that? 10.20 or 10.19 now? Both should be close to one of those two. Let's take a look and see which one we get. So first up is okay. So finding the discount, we're using our simple interest formula. Our 12,000 goes in as the principal, 0.097 as the rate, and 180 over 360. So that's going to give us, that's not the tool I wanted, $582 is our discount, correct? So that means our proceeds, which is found by doing what? Yeah, 12,000 minus the 582, so $11,418 is our proceeds. And then okay, so what do we do with that? We're going to combine those two. Good. So 582 equals 5709R. And then divide. 582 by 5709 is 0.10194. Casey, it looks like you rounded up again too quick.
why can't you do that?
Yeah, let me show you.
Well, I just don't understand if you round, would you round the 10th first?
No. When you round, you'll only, and this is, I've caught you doing it before, and I catch a couple people doing it. When you round, you only round once.
So if you round to the 100th, you go to the 1,000, so it's higher than 5.
Yeah. So let's move our decimal point here first. This is 10.194%. When I say round to the nearest 100th percent, you have to first be a percent, which we just did. Then you go to the 100th place, which is right there. Then you look for the digit after that, which is the 4. And that's it. That's just one step, and you're done.
We're good now.
Yeah, okay.
That's the first time I've ever told to do that. So.
Okay. Well, I know a lot of people do. They'll look, like if let's say there's a 6 here, they'll look at that. Well, the 6 would make that a 5, then the 5 makes that a 10. You know, they double round. No, when you round, it's only one digit. Just the one digit you're looking at. Look what's after it to see whether you stay the same or go up. That's it. Because remember, what that rounding is saying is on a number line, physically, this is between 10.19 and 10.20. Well, right in the middle of that is 10.195. Right? Anything less than 10.195 is going to round back to 10.19. Anything more is going to round up to 10.20. And if it's exactly 10.195, we round up just because we have to go somewhere. Okay. Yeah, I see that mistake a lot.
I don't ever be told what to do with it.
Yeah.
I was like, oh, there's a 9 there, we'll round down.
We'll round the 9 up, then we'll round this up, and then, yeah.
What if we use a new process, Todd?
Well, you know, someday when you rule the world, you can invent your own math and force everybody to do it. If I ever rule the world, I plan to. You'll abolish math? All you need to know about math when I rule the world is make checks payable. Just kidding. So anyway, you might be wondering to yourself, yeah, it's called taxes, darn it. Yeah. That'll be nice. That'll be good. Okay. So, you might be wondering to yourself, why would we ever use this? I'm trying to tempt her right now. What good could this discounting a note, what could it possibly be used for? Well, I mentioned last week, if you have a sum of money that you know you're going to get at a certain time, like let's say you have an inheritance that you can't access until a certain date. A lot of times, especially if you're a minor, it's set up you can't access it till you're 21 or 25 or whatever. So let's say you have something that you can prove that you are definitely getting this amount of money on a certain date. Let's take a look at that. Let's say you're getting an inheritance. Helps if I can spell it. Inheritance. Pretend I spelled that right. Even if I didn't. Let's say you are going to get $60,000 in exactly 2 years. The bank is going to look at that. If they're doing simple interest, they're going to look at that and say, okay, you want the money now, 2 years ahead of time. In 2 years, we're going to collect that money. When you get that inheritance, it goes straight to us. You have no, you're selling your rights to that money to the bank. So they're going to say, okay, our terms, because we're not going to get any payments between now and then, we're going to have to wait the full 2 years, we're going to charge you 12%. Debbie, for you, that would be 14, just because you're being mean today. Or you want the money 2 years before you're actually going to get it. Let's say you're 23 and you're going to get it at 25. So the bank's going to give you the money now, and then in 2 years they get the inheritance. Well, they're not going to give you the $60,000. What they're going to give you is a discounted amount. Because all they're going to get at the end of the 2 years is that $60,000. So that's where a simple discount note comes into play, is they know that at 2 years you're going to have $60,000. They don't know whether you're going to have any more than that to pay interest or not, so they don't want to take the risk of saying, in 2 years you give us $60,000 plus interest. They don't know if you can afford that, but they know you're going to have $60,000. So they're going to use a simple discount note, where they're going to give you a discount based on the $60,000, that 12% rate, so 0.12, and 2 years. which is going to come out to $14,400 in interest or discount. What does that mean for the proceeds? Yeah, we're going to take that $60,000. We're going to subtract $14,400. We're going to get $45,600 is the proceeds. So because you wanted it 2 years early, your $60,000 turns into $45,000. Now think about that now. 12%, that's 12% per year. So 2 years, that's 24%, or basically 1/4. If you got a lower rate, it won't be quite so bad, but it's going to be a significant amount. The bank is giving you this money ahead of time with no payment. What's that? Personally, I would too if I could, but you never know. Maybe mom needs an operation, or you're... Well, true. Not necessarily. For an inheritance, you can, I believe it used to be $400,000 you could inherit without taxes. I think now it's gone up to $1 million per person. So you're safe. So you can safely put me in your will now and not worry about my tax problems. But you know, it would really be more healthy for them to make it on their own. A good mother would let them struggle and be strong kids. Okay. So now we need to figure out an effective rate. Because it was a 12% interest rate, the effective rate really blows up here, especially since it was 2 years. So our effective rate, we're looking at $14,400 in interest times $45,600 is our effective principal, our actual proceeds, times R times 2. So we combine the $45,600 and the 2 to give us $91,200 times R. And then divide by 91,200. So 14,400 divided by 91,200 is 0.1578945. 0.157895. I probably went one more digit than I had to there. Once again, let's say we're going to the nearest 100th percent. So first we change this to a percent, 15.7895. 100th digit is what digit here? The 8. After the 8, we see a 9, which tells us to round up. 15.78. So 12% turns into 15.79% because it's a discount note.
Why are they going to be like that? Guys be happy.
If you had a chance to turn to somebody who is desperate and say, "You're going to pay me this much money," wouldn't you?
No.
I mean, you do realize that your credit rating is based on a couple of things. One is your credit rate, your interest rate is based on a couple of things. One is your credit history, your credit score, basically. 2 is your income, your debt to income ratio, your income and expenses type stuff. 3 is your desperation. Why do you think credit cards are more expensive than like a car loan or a home loan? Because a home loan or a car loan is usually something you've saved up for, you've prepared for, you're not desperate for, you've shopped around a little bit. If you don't get it right now, you've got other options. Credit cards, generally if you're using a credit card, it's because you need the money kind of like right now. It's something you didn't plan so much for or whatever. You're more desperate. You have an immediate need there. So if you ever go into the bank asking for a personal loan, which is more and more common these days, you know, $1,000 or $1,500, usually like in November before Christmas, banks get flooded with requests for Christmas loans or personal loans. On a personal loan, all you do is you sign a piece of paper saying, I will pay this back. No collateral or anything like that. Basically, it's like a credit card because there is no car or house or anything else backing it up. Because it's a personal loan with no collateral, again, it's a bigger risk for the bank, but also it's basically you're more desperate for the money. But when you go in and ask for it, you can call them collective and ready to walk away. And the more desperate you seem, the higher rate they're going to quote you.
Really?
Yeah. Believe it or not, I mean, well, most banks say that they won't, they're not going to, they have a set rate for certain types of loan based on your credit rating and stuff. I've gone into a bank. For a personal loan, that's not true. For auto and home mortgages, that's generally true. Although your home mortgage can change by over a full percent, depending on what your credit rating is. I've seen people when you could get I could walk in ask for the same mortgage and get bless you, like a 4.1%. A friend of mine with a lower credit rating went in and they quoted him 5%. Same loan, same property. Same bank, same loan officer. Yeah. So, and I've had it with personal loans where with my business, I needed, $1,000 to pay my employees for the week or whatever. Going to get it back in 2 weeks. I've gone in there and they've quoted me 8.5%. I said, well, I'll figure out something else and started to walk out. Well, wait a second. And I've got them to come down from 8.5 down as low as 6 3/4. So it's negotiable too. Another example of a simple discount note. Ever hear of a treasury bond? Slang term for them is a TBill. Yeah, the old savings bonds. Yeah. When you were born, your grandparents bought you a $50 savings bond, so when you're 18, you have $50. Yeah, that's cool.
They're useless.
Yeah, they might be worth something. Did you get them when you were born or graduation? Or?
I've got them since I was born, and then for Christmas, my birthday, Halloween.
Most of them have a maturity date. There's usually an interest rate quoted on them when you purchase them. Let's say you get a 5-year treasury bond. Let's do the example here. Let's say you get a $200 5-year, and it's quoted at 6%. Generally, bonds are a little bit higher. The worse the economy is, the higher the rate is on a bond. So when your savings account rates go down, and unemployment goes up at the same time, usually your bond rate goes up. So that's when you pull money out of your savings account and buy government bonds. Anyway, well, it's a discount. It's basically a discount note, but instead of being the borrower, you're now the lender. The borrower is the federal government. So what you're doing is they're going to give you the discount, or you're figuring out the discount, which is going to be the $200 times 0.06 times 5, which is what, $60? Does that sound right? So that is the discount. That's how much interest you're going to earn on that over the 5 years. What you pay is the proceeds. So 200 minus 60, you would pay $140 for that. But just like if you're borrowing money and they give you a simple discount note, there's still an effective rate that's higher than the stated rate. Let's go through that here. You've got $60 in interest on $140 all you actually had to pay over 5 years. So you're going to do the 140 times 5, which is $700. And you solve by dividing by 700. So 60 divided by 700 is 0.085714286 approximately. Is your rate. You can double check me, it's right. What do we do with that? Let's say we're rounding the nearest 100th of a percent again. Move it over 2, so it's 8.5714 is far enough percent. And then the 100th digit is the 7. Round up or down? Stay the same, round down. So 8.57. So even though it's stated at 7%, you're getting 8.57% return on your money. That's not bad. It's better than a sharp stick in the eye.
You was making ass with how much they figured, wouldn't you?
Yeah. They do have to, if you ask, they have to give you what's called a yield, which is the effective rate.
They can't just give you the sum.
No.
What happens if you do it more than 5 years?
Well, the 5% or 7% interest or whatever, the 6% in this case, they quoted you is only good for the 5 years. After 5 years, you don't have to cash them in, and they still will continue to draw interest, but it'll drop down to usually a lower rate.
But it'll still, if you cash it in like 50 years, it would.
You're still going to get interest. Yeah. Generally, what they do is if interest rates have gone up, they just let it stay at the 5 or the 6%. If interest rates have gone down, they drop it down to that new lower rate. Sometimes, even if interest rates have gone up, they'll drop it down from the 6% a little bit anyway, just because they can. Any questions? Okay. It's 5 minutes early, but that's a good time to take our break, because when we come back, we're going to talk about discounting a note, which is kind of a long process, so I don't want to start it right now. So let's take 10 minutes or so. We'll come back at like 6:25.